All right, guys. This is the 5.2 video on some probability rules. And yeah, we'll kind of crank this. So in the first video, we kind of talked about the state plan to conclude, kind of doing all 4 steps, kind of running some simulations, how to use calculators to help us do that. And so now we're going to talk about some actual probability rules. So here we have this table about the probability that the probability of a certain score on the AP test. So here you have the score, and then you have your probabilities. And the first question is find the probability that students score 3 or better. Okay. So when we write this out, the way we denote this, the way we write this is we say the probability that x is greater than or equal to 3, where x represents the score you get. So x, and put on the side, x equals score. Okay. And all we're doing is we're just going to add up these 3 probabilities to get a score. So then you just write that out. You say equals 0.252 plus 0.192 plus 0.134, and that gives you some number. Okay. On the next one, similar type of thing. We're saying what's the probability that a student did not get a 1? So that's the same thing as saying the probability that x does not equal 1. Okay. Which is the same thing as saying 1 minus the probability that x equals 1. And I want you to think about why that's correct. Okay. But essentially what we're saying is, well, if we can't, we want the likelihood that you don't get a 1, right? And we know from our basic probability rules that this whole thing has to add up to 1. So if I want to just get rid of this 1, I'm adding up these 4. When I add up these 4, it's the same thing as doing 1 minus just this first one here, which is probably the faster way to do it. But you could do either way, right? You could add up you could add up all these 4 if you wanted to, and that will give you the right answer. Or you could just do 1 minus this first one, and that'll also give you the right answer. So either way, you're going to get the right thing. Okay, so what is a sample space? I'm just going to get some more definitions. A sample space is the set of all possible outcomes. Okay. So, heads, tails. You also include, when you talk about sample space, you also talk about like the empty set, which is like where nothing happens, and then the full thing where you get both heads and tails. So we'll talk about that more in detail as we get further along. Okay. What is a probability model? It's a description of some chance process that consists of 2 parts. One being a sample space, and 2 being a probability for each outcome. How do you verify the probability model is legitimate? Make sure it sums to 1. Okay, so that's going to be one of the questions that they put on the AP test, probably a multiple choice question. Is going to be, they're going to give you a table, and one of the things you're going to notice is that probably one of them doesn't add up to 1, and so they're just seeing if you checked, is it legitimate first, right? So make sure everything sums up to 1. What is an event? Any collection of outcomes from a chance process. An event is a subset of the sample space. Okay. 5 basic probability rules. We kind of already talked about this, so I'm not going to rewrite them again. Right, so your 5 basic probability rules are, it's got to be between 0 and 1. It's got to add up to 1. The complement, which is the likelihood that something's not going to happen. There's 1 minus probability that it does happen. If all outcomes are equally likely, then the probabilities are the same. And if they're disjoint, then you can add the 2 probabilities together to find both. Okay. So that's going to lead to the important thing, which is what are mutually exclusive, meaning that they have no intersection. So when I draw this out, you just have, here's event A, here's event B. Okay. That's kind of how this works. And so now we're looking at, okay, we want to make some two-way tables and talk about some probabilities. And so here we have the scenario, and we're looking at the likelihood of getting tacos given that someone wins. And so we can kind of fill this out real quick, try reading the problem. So just gonna make a quick little table. Okay, and so now we have win, not win, free taco, no free tacos. And we can kind of just read the problem, kind of fill this out. So if we won a total of 41 of the home games, so I can put a 41 on the outside here. And there's a total of 81 in the very bottom corner. So the outside kind of represents your total. It's called your marginal distribution, which we're going to talk about. And you can kind of fill this in. You know, this has to be a 40, right? 40 plus 41 equals 81. And then you kind of keep going from here. And you get 26, 15, 4, and 36. And the way I got these numbers, guys, is by reading the problem. So what I did was I just kind of noticed that a couple things. So the first swing is in 26 of the games, the Diamondbacks won and gave away free tacos. So that's going to be this number right here, right? If you think about it, we have winning and free tacos, so that goes in this box right here. And then we also know that, if we keep reading, that we gave away 30 games, we gave away free tacos. So we know that this total, okay, so we know that this total here has to be 30. So once I figured out that this top box here is going to be a 26, then I can kind of fill in this with a 4. Okay? And if I know my total number of games is 41 that we won, then I can kind of fill across and just kind of fill this in. So 26 plus 15 is 41. If we know that this is 30 here, we know that this number has to be a 51. Once you figure out 15, you can then fill in this third bottom right one at 36. So you kind of just take it piece by piece until you get these numbers. Okay, and I'm going to keep this table up because we're going to need it for the next couple of questions. And so I'll just read them out loud so I can kind of keep this table up. So the first one is, what's the probability that they won the game? Okay, so that's the first question on page 45. And basically what you're looking at here is the likelihood that they won, which is 41 out of the total 81. Okay, so just write 41 out of 81. You can turn that into a decimal if you want to. Okay, so that's the first one. Second question, find the probability they win and get tacos. So win tacos, that's this box right here. Okay, out of the total 81. Next one, what's the probability that they win or there are free tacos? Okay, so we have 41 wins, plus we need to look at the likelihood that they give away a free taco or not win, which is this box down here. Add those together, you get 45. 45 out of 81 is your probability. Okay. So that's kind of the idea behind all this. And so now we look at a couple of things. We look at addition rule, the general addition rule, which is the probability of A union B. So whenever we see this U, it means union, is equal to the probability of A plus the probability of B minus the probability of both. And what I want you to think about is, okay, well, if I draw a Venn diagram, okay, so here's scenario one where we have some overlap. So here's A, here's B, okay? When I add up A, so if I add up this section here, and then I add up B, this green section, well, what's going to happen is you have this middle section there, you're counting twice. And so that's why we remove A and B. Okay, so we add them both and then we take away the intersection because we're double counting this middle part. Okay, but now what happens if, back up a little bit, if I have two separate circles, if I have mutually exclusive events, so there's no overlap, which we talked about So I have something like this. Well, the intersection here is just going to be 0. And so then you just simplifies down to the probability of A plus the probability of B. You just add these two together. Right? Because you'd have the pink plus the green minus the intersection, but there is no intersection, so that's going to be 0. Okay, so we can kind of use these probability rules to kind of answer more questions. So given that they won, or sorry, given that they had free tacos, so going back to the table, that would be out of the, how many tacos do we have? Out of the 30 free tacos, what's the likelihood that we won? Okay, so here you're looking at that first column, you're going to have 30 or 26 out of 30. Okay, and then if you do the other way, you say, okay, given that we won, so here this becomes your denominator. I'm going to label that with a D. Right? It says given that we won, so we're looking at the win row. So out of the 41 games that we won, how many times did we give away free tacos? That is 26. Okay, so that leads to the next question. What is conditional probability? So conditional probability is a little equation here. So I'm going to write this out. So we have the probability of A given B. So you're conditioning on this event B is equal to the probability of A intersection B divided by the probability of B. And if you want to flip this around, you could say probability of B given A. It's the same thing, just flip around. What goes on in your denominator? You have the probability of B and A over the probability of A. Okay. And again, if you want to think about this, okay, so if you have these overlapping Venn diagrams, okay, well, we're saying the probability of B and A, or A and B, is going to be this middle section. So, and then your denominator is going to be, let's say we're doing this one here, B given A, here's A, right? It's going to be all of this. And if you want to think about it, right, probability is just like your likelihood of success out of total outcomes. Okay. Well, basically what we have is we have when you read this out loud, you have the probability of B probably that B happened given that A already happened. Okay. So this is that little middle part, that green part, and then A is just this whole thing. So we're just going to divide by the whole thing, right? So we have what's on the inside divided by the whole thing. And so you can use conditional probability to tell if events are independent. It's kind of a big concept. So here we look at the probability of A given B. That's equal to the probability of A. Right, so what you're saying is that this condition, right, when I conditioned on B, it didn't make a difference, and therefore, when I do the intersection, it's not going to have an impact on the overall thing, right? So that's basically all you're saying here, and it's the same thing if I flip it around. Probability of B given A is equal to the probability of B, right? So again, if I condition on A, it didn't make a difference, so therefore they are independent. And so when you look at this in the baseball problem, what you're going to look at is you're going to look at a couple different things. Basically, you're going to look at the probability of just getting a taco. And that's 30 out of 81. The probability of getting a taco given that you won, so you're just going to condition on given that you won. And that's 26 out of 41. And then you're going to look at the probability of getting a taco given that you didn't win. So I'm going to call that win complement. And that is 15 out of 41. Okay. And so when I look at these, I can tell right now that these are not equal. And so therefore they are not independent, right? So these are dependent events. just based on that, because I know that based on my condition, the probabilities are going to change, and therefore they're dependent on each other. Okay, I want you to try out the next page on your own. We'll kind of go over it in class, and that's only going to lead to one more video on just conditional probability. So that's it for this video, guys. Again, try the problem on your own, and we'll go over it. All right, thanks, and have a great day.